Hello and welcome back again. Today we're going to work on the basics of exponents and multiplication for pre-algebra. If you are doing the GCSE exam, you can also watch this video and this will help you in just refreshing your memory about some simple exponent rules. Alright, so the rules of exponents are pretty simple, right? One of the first rules that you should always remember is, first of all, if two numbers with the same base, right, so a and a are the same, but with different powers are multiplied, then you can add their powers. So a can be written down as m plus n, right? In arithmetic terms, or in terms of numbers, this means, for example, if you have 2 to the power of 3 times 2 to the power of 4, you can write this with the same base, but you can add their powers. So 2 to the power of 3 plus 4, which becomes 2 to the power of 7. Let's go ahead and do some examples together. Example 1. Simplify each expression. A, 3 times 3 to the power of 3. B, a to the power of 5 times a times b to the power of 2. And C, x squared times x cubed times y to the power of 4. Okay, so the first of all, when there's no power, that means it's actually being raised to the power of 1. So 3 times 1, 2 to the power of 1 times 3 to the power of 3. We just learned that you can add their powers right there. This is rule 1. So you can write this as 3 to the power of 1 plus 3, so 3 to the power of 4. That's the final answer. As for the next one, for B, it says a to the power of 5 times a times b to the power of 2. Now, when there's nothing, again, the power is 1. But you can add the power of these two with b squared, right? So they have to have the same base. So this is something you got to be careful about. So you can write a 5 plus 1, but b squared remains as it was. So a to the power of 6 times b squared. Let's take a look at C now. It says x squared times x cubed times y to the power of 4. All right. Now, as for this one, you can just write them as x, 2 plus 3, times y. The power of this one is 1, 1 plus 4. So you get x to the power of 5 times y to the power of 5. There you go. Let's go down. Now, the next rule that is also quite important in exponents is the fact that if you have a to the power of m raised to another power, so a number raised to another power, you can write them with multiplying the powers. In arithmetic terms, for example, 2 to the power of 3 to the power of 4 can be written down as 2, 3 times 4, which becomes 2 to the power of 12. Now let's go ahead and do some examples together. Example 1, once again simplify. A, 3 to the power of 2 to the power of 3. B, m to the power of 3 to the power of 2. And C, 0 to the power of 5 raised to the power of 8. Okay, now once again, using the rule, we know that their powers are going to get multiplied together. So you get 3, 2 times 3, 3 to the power of 6. You can also simplify this further, find out what that equals to. And then for B, once again, same thing. So their powers get multiplied, 3 times 2, so m to the power of 6. And for C, 0 raised to the power of 5 times 8, so 5 times 8. Now, if you guys recall, anything raised to the power of 0 raised to anything is always equal to 0, right? So 0 raised to 5 times 8, which is essentially 40, is still going to give you 0. But keep in mind that any number raised to the power of 0, however, is going to give you 1. For example, 2 to the power of 0 is 1. 200 to the power of 0 is going to give you 1. 2 million, not necessarily the 2's, but any number raised to the power of 0 always gives you 1. All right, let's go ahead now The next rule that is also quite important when it comes down to exponents in pre-algebra is when two numbers that have the same base are being divided. So this is rule 3. For example, a to the power of m over a to the power of n. You can write them as with the same base, but this time, instead of adding their powers, you're going to subtract them. For example, and keep in mind that a cannot be equal to 0. Keep in mind that it cannot be equal to 0. Now, for example, in number terms, let's say you have 4 to the power of 5 over 4 to the power of 2. How can you write this using the same base? First, you're going to write 4, because they have the same base. They both are 4 to the power of something. Then you're going to subtract their powers. So 4 to the power of 3. There you go. Okay? Now, let's go ahead and do some examples about this. Example 3. Once again, simplify. A 3 to the power of 8 over 3 to the power of 5. B, scroll down a bit. A to the power of 4 over a to the power of 2. And then C, 12m to the power of 5 over 3m. Okay. Now, over here, one thing that you have to be careful is, first of all, 3 to the power of 8 over 3 to the power of 5, once again, is going to be the same rule, so you can write them with the same base, but just subtract their powers. So 8 minus 5, that will give you 3 to the power of 3, which is essentially, you can find it out, but you don't have to right now, unless the question asks you to leave it in the simplest form. For B, it says a to the power of 4 over a to the power of 2. You can write it again as a to the power of 4 minus 2, right? Because you want to write it with the same base, and according to the formula right here, the rule, what happens is that you should subtract their powers when you're writing them with one base. So a to the power of 2. Now let's take a look at C. C is a bit tricky, and this is the one that I was going to say you have to be careful about. First, you have to divide the numbers. So 12 divided by 3 is 4. And then you have to take care of the power. So you have 4m, 5 minus 1. So the final answer is 4m to the power of 4. All right. Now let's go ahead and take a look at some other examples concerning the rule concerning the rule that we just talked about. Before this, a to the power of 0 is equal to 1. Basically, any number raised to the power of 0 is 1. So let's say we have, for example, negative 8 over negative 8. Both of them are raised to the power of 2. Now, here is the deal. First of all, they have the same base, so you can write them as negative 8 to the power of 2 minus 2, right? Which becomes negative 8 to the power of 0. So the final answer is 1. Now let's say, for example, they give you something like 6b cubed over 18b cubed. How do you do this one then? Well, for this one, 6 divided by 8 is going to give you, you can divide both sides by 6, you get 1 on top, and 18 divided by 6 is 3. And then you have b to the power of 3 and b to the power of 3. You can separate the fraction and write it as 1 over 3 times b, 3 minus 3. 1 over 3 times b to the power of 0 is 1. So the final answer is going to be 1 over 3. All right. Now, let's go ahead and do some more examples on this. For example, let's say they give you c x to the power of 5 times y to the power of 6 over x to the power of 5 times y to the power of 3. Now for this one, similarly, you just have to write, you can write them separately like x to the power of 5 over x to the power of 5 times y to the power of 6 over y to the power of 3. And then you have to subtract their powers according to the rule. If a is over to the power of m is raised to the power divided by a to the power of n, you can subtract their powers and write them as one base. So similarly over here, you can have 5 minus 5 for x, and for y it's going to be 6 minus 3. So you get x to the power of 0 times y to the power of 3. Thus the answer will be y to the power of 3. All right. Now, the one last rule that is also quite important for the PreAlgebra book is if you have a number raised to the power of a negative power, you can write it as the reciprocal but with a positive power. For example, if 3 is raised to negative 2, you can write it as 1 over 3 to the power of positive 2. Or if 2 is raised to negative 2, you can write it as 1 over 2 but with a positive power. And this simplifies into 1 over 4, by the way. Now let's go ahead and do some examples of this. For example, this is example 5. Once again, simplify each expression. A 5 to the power of 6 over 5 to the power of 8. We're going to get, you can write them again with the same base using the rules that we learned before. So 5, 6 minus 8, that gives me 5 to the power of negative 2. Now I have to use this final rule right here. This is probably rule 5 if I'm not counting it wrong. So this one can be written down as 1 over 5 to the power of positive 2. So 1 over 25 is the final answer. Pretty easy there. Let's take a look at another one. Some more complex questions. For example, B, 3y to the power of 8 over 9y to the power of 12. And C, x2y3 over x3y. Now for this one, once again, you can separate the fraction and the numbers, so you can write it as 3 over 9 times y over 8 times y to the power of 12. This one, 3 over 9, becomes 1 over 3. Just simplify both sides of the fraction with 3. The other one becomes y to the power of 8 minus 12, right? You can subtract their powers according to the rule a to the power of m divided by a to the power of n, which is a to the power of m minus n. So that's going to give you 1 over 3 times y. 8 minus 12 is negative 4. All right. Now, the next step is you can just write it as 1 over 3 again times 1 over y to the power of 4. And then you can multiply the denominators and write it as 3y4. Or just leave it as this form. Now, let's take a look at this question, the final question for this video. Now, once again, you can write this as x to the power of 2 minus 3. So I just separated the fractions. I skipped a step. And you can write the other one as 3 minus 1. So this one becomes x to the power of negative 1 times y to the power of 2. The first one can be written as 1 over x times y over 2, y to the power of 2. And now notice that when y squared is written down without the 1 over it, that means that the denominator of y squared is actually 1. So you can multiply this with this and the top with top. So you get y squared over x, which is your final answer. Now, thank you for watching. In the next video, we might go ahead and do some challenging questions based on the same topic. Make sure that you practice the other questions for these types of examples. Thank you for watching.